today we are going to discuss the binomial theorem. Okay, so what is the binomial theorem? Binomial theorem is this theorem is used for the multiplication, or we can say the expansion of the higher degree binomial term. But before going to start today's topic, I want to ask some questions from the previous topic, previous years, previous lectures. Going to start today's topic, I want to ask some question from the yesterday's lecture. Can anyone give me the answer of the question 3? Express square root 45 in form of a root 5. Unmute yourself and give me the answer.
3 root 5.
3 root 5. It means the value of a is 3, right?
Yes.
Give me the answer of question 6. Log x 4 minus log x 16.
Log 4.
No.
5.
Log 1 by 4.
Log x 1 by 4.
Log x 1 by 4.
Very good.
Square- log x 1 by 4.
upon
Log
16. Yes, yes. Log x 1 by 4. Now give me the answer of question number 7.
2 raised to 5, 32. A is
2
equal to
raised
32.
to 532.
Very good.
2 raised to 5, 32.
And what about the question number 8? What about question number 8? What is the value of a and b? Dear students,
A is equal to 6, B is
6
equal
and
to
9.
9.
b9.
B is equal to 9.
Perfect.
A6 B9.
Yes,
A6
yes.
B9.
And what about question number 9?
X is equal to 7.
X.
X is equal to 7.
Oh,
X is equal to 7.
these questions are
7, 7.
from yesterday's lecture, but today we are going to start new topic, that is binomial theorem. And for the binomial theorem, see, let's start with, okay. Now what is binomial theorem? A binomial, anyone can see this screen?
No, ma'am.
No, ma'am.
No, ma'am.
Okay.
ma'am.
Okay.
No,
ma'am.
Okay, right? Now, a binomial is a polynomial with two terms. What is binomial? Binomial is a polynomial with two terms. This is 5y cube minus 3, right? What happens when we multiply a binomial by itself many times? See, suppose we have a binomial a plus b. If we multiply a plus b with a plus b, then what we get? A square, a into b,
A square plus 2ab plus b square.
2ab plus b square. Okay.
I know.
Now, next, what about a plus b into a plus b into a plus b? It means if we multiply 3 times, then what? Then a plus b the whole cube, right? So a plus b the whole cube, it means a plus b into a plus b whole square. The answer of a plus b into a plus b is a square plus 2ab plus b square. So a square plus 2ab plus b square into a plus b. If we multiply these two brackets, then we get the answer a cube plus 3a square b plus 3ab square plus b cube. It means this is the formula of a plus b. This is the formula of a plus b whole square. This is the formula of a plus b whole cube. right? Similarly, this is if we multiply a plus b 4 times, then our answer is this one is a plus b whole cube into a plus b. So this one is a plus b whole raised to 4, right? So this is about a plus b whole raised to 4. So to calculate, get longer and longer as we go, but there is some kind of pattern. See, uh, Dia, please give unmute yourself and give me the answer. Can you see any kind of pattern here in this or formula? From this first, second, and third,
Yes, ma'am.
just
This
Dia,
triangle. Triangle.
I asked to Dia. Dia,
Yes, ma'am.
can you see any pattern in
The
this?
power.
Huh? Yes.
Yes, ma'am. The power remains same in all the three.
Power remains same. Okay.
Yeah.
From the first equation, we can say power remains same. Here 2, 2, 2. Here in all terms, the power is 3. For the next one, the power is 4. But if I want to write this formula for the higher power, here the a plus b whole raised to 4. If I want to write the a plus b whole raised to 5, whole raised to 6, whole raised to 7, then what kind of pattern is going on here?
Pyramidal pattern.
Pyramidal pattern.
It's a binomial formula theorem.
Yeah, we are going to use the binomial theorem, but
Ma'am, Pascal's triangle.
perfect. Pascal
Pascal's
triangle.
triangle.
Yes.
Then,
Pascal triangle.
yes, ma'am. Yeah.
So here, see the power of A. See, here we have two terms, right? A and B. So power of A is decreasing in all the terms. So power of first term is decreasing. See the here power A plus B the whole square. Sorry, this one is. See, this one is a plus b, the whole square. So the power of a is first here 2. So the power of a is 2. But then power of a is 1. Then power of a is 0, right? And for the next second term, the power of b here 0, then 1, then 2. Similarly, this one, a plus b the whole cube. Then we start, the power of first term is 3. But then the power of a is decreasing and the power of b is start with 0 and it is increasing. So this pattern goes same for all formulas, right? First, second, third, and so on. So the pattern, if I want to ask to write a plus b whole raised to 50, then what you will do? Then what you will do? You get the power. You will start with a raised to 50, right? B 0. So b raised to 0 is 1. The next is a raised to 49. B plus a raised to 48. B square up to so on. Okay. And last b raised to 50. Right? This is the formula for a plus b whole raised to 50. But what about the coefficients? Here the coefficient is 2. Here 3, 3. Here 4, 6, 4. So if I want to ask a plus b whole raised to 50, then you get the power, or I can say you get the exponent directly. But what about the coefficient? So let's start for that. See, that pattern is summed up by the binomial theorem, that is a plus b whole raised to n equal to This is the summation because we get there are so many terms. So this is the summation k 0 to n nck a raised to n minus k b raised to k. Okay, let us check the formula. If, see, this is the a plus b whole square. So a this one is a plus b whole square, right? So summation k 0 to 2 and C2, sorry. Here your n is 2, so 2ck, a raised to 2 minus k and b raised to k. So here we are using nck. Nck is nothing but NCR. And you very well aware about NCR, that is, please unmute yourself and give me the answer of NCR. Formula
N
of
N factorial
factorial
upon
upon
r factorial into n minus r factorial.
very good. R factorial upon n minus r factorial.
R
Okay. Krish, give me the answer of NC0. Krish.
1.
1.
1.
Yuvraj, give me the answer of NC1. Yuvraj, what is the answer of NC1? Harshal, answer of NC1?
N.
Very good, N. Students, when this term is 1, our answer is the upper term. NC1 is 1, 2C1 is 2, 3C1 is 3, 10C1 is 10, right? And what about NCN?
Ma'am, it's 1.
Okay. See, so please remember these three values. NC0 is 1, NC1 is n, NCN is 1. And the next is NCN minus 1. Anyone? What about NCN minus 1? Harshal?
Ma'am, can I try?
Yeah, sure.
N factorial upon n minus 1 into n minus 1 in minus n. That will be minus 1 something.
Keep
N
on.
factorial upon n minus 1
upon
factorial.
n minus 1 factorial.
I want
It will be 1 minus n. Ma'am, n?
It's n, only n. The
Yes,
answer is only
very
n.
good.
N.
So students, it will help you for the calculation of examples. If you remember these 4 terms, it will help you in the calculation of example. See, NC0, if this term is 0, our answer is 1. If both are same, answer is 1. NC1, then the answer is n, and NCN minus 1 is again n. See, if I ask you 4C3, see, this is our n, and this is our n minus 1. So 4C3, it means 4. Understand? This one is n. See, which term? This is n, and this one is n minus 1. Our n is 4, n minus 1 is 3. So our answer is, if I ask you 8C7, understand? What is 8C7?
8.
8.
Okay, like that. Okay. Similarly, 5C5. What about 5C5?
1, ma'am.
1.
1.
Both are same, then answer 1. So, it will help you for solving the examples. So, let's start here. Summation k 0 to 2. So let's start. Please mute yourself. 2C0. Here we start with 0. So 2C0. A raised to 2 minus 0. So a square. B raised to 0. That is 1. You all know. 2C1. A raised to 1. B raised to 1. Next 2C2. A raised to 0. And B square. So this 2c0, see nc0 is 1. So 2c0 is 1. This one is 1. B raised to 0 is 1. So our first term will be a square. 2c1 is 2. See nc1. nc1 is n. It means 2c1 is 2. So middle term is 2ab. And the last term, NCN. NCN is 1. It means 2C2 is 1. A raised to 0 is 1. So B square. Right? So A square plus 2AB plus B square. This is the formula. This you can also check with the help of the binomial theorem. A plus B whole raised to 3. See, for whole raised to 3, you get this one. For a plus b whole raised to 4, you get this one. Right? Now, exponents. Exponent says how many times to use something in a multiplication. See, these two indicate that 8 multiplied 2 times. Right? 8 into 8. If exponent is 1, it indicates the value itself. But if 8 raised to 0, if our exponent, this exponent is 0, then we get the answer 1. This is for the just any number. But if we have binomial a plus b raised to 0, a plus b raised to 0, it means here a plus b raised to 0, then we have 1. A plus b raised to 1, that is a plus b itself. A plus b raised to 2 means a plus b into a plus b. It means these exponent tell us how many times the binomial multiply. A plus b raised to 0 means this binomial multiply 0 times. So we get answer only 1. This to 1 means the value itself. And if a plus b raised to 2, it means the binomial multiply 2 times. So, see this one. Okay. Now, similarly for a plus b raised to 3. So, if the pattern is what, students? Here a cube plus 3a square b plus 3ab square plus b cube. It means the power of a here is go down. It starts with 3 and up to 0. So, power of a is 3, 2, 1 and 0. Okay, the power of a is 3, power of a is 2, here 1 and 0. And the power of second term is going up. Here b is 0, power of b is 0, then 1, then 2, then 3. So, here k equal to 0, for any 0 to n terms, we start k equal to 0 up to the given terms. Suppose you have asked here for n equal to 3. N equal to 3. It means your power of a plus b whole raised to 3. You have to direct your power of a is 3, then 2, then 1, then 0. And the power of b is 0, 1, 2 and 3. You get directly the power of both the terms. But what about the coefficients? How we find the coefficients? And for the coefficients, we use Pascal triangle. See, this one is used, this one is a plus b whole raised to 0. This a plus b is a plus b raised to 1. This a plus b whole square. and this is for a plus b whole cube. So this one, the coefficient of this one is 1 and 1. The coefficient of this one is 1, 2, 1. The coefficient of the last equation is 1, 3, 3, 1, up to so on. But how this triangle is made up? See, here 0, this one, see, show you. Right? Okay, this one. 1, 1 plus 1, 1, 1, 2, 1. So this Pascal triangle is made by the addition of the upper one. See, here 0, this one is 0. So 0, what happened? Drishti, what your problem? Does this mean that number of the terms in any binomial is n plus 1, where n is the power of the binomial? Yes, yes, Drishti. If n is the power of the binomial, then the number of term is n plus 1. Okay. Now, I just want to tell you that how this coefficient occurs. This coefficient occurs from, see, this one is 0. 0 plus 1 is 1. This one is also 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 0 is again 1. 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 0 is 1. Similarly, for the next one, 0 plus 1 is 1, 1 plus 3 is 4, and up to so on. Okay, so it is, this Pascal triangle is easy when your power is low. If I ask a plus b whole raised to 5, then it is again easy. But what if I ask a plus b whole raised to 50? Then how you made this Pascal triangle? It is very long process. It is possible, but it is very long process. So, for the solution of this problem, we are using this formula, and this formula is a plus b whole raised to n summation k0 to n ck a raised to n minus k b raised to k. Okay, I will ask you one question. Give me the answer of 1 plus b whole raised to 3. Give me the final answer. Please calculate. I will give you 1 minute. 1 plus b whole cube. I will ask any students. Give me the answer 1 plus b whole cube. Yes, Yanshu?
1 plus 3b plus 3b square plus b cube.
Okay, now mute yourself. See, students, the power of 1 raised to 3 is just 1. Okay? Plus, here, 3 power of 1 square. See, I will write the direct answer here. 1, 3, b, 3b square plus b cube. Okay. How you get this answer?
I'm using identity a plus b the whole cube.
Okay, and if
Exponents का
you
तो पता है वो तो
if you
बढ़ेंगे.
want to find this expansion, okay, if I ask you 1 plus b whole raised to 5, then 1 plus b whole raised to 5. Abhi,
And we will
We will
increase
use
the,
from
firstly
the
we will keep the coefficients, and then the power of the b, as we know that it will increase.
okay,
Likewise of 1
using
plus
binomial
b
one.
plus b square plus b cube plus b4 plus b raised to 5.
yes, good.
And the coefficients by the Pascal's triangle.
Perfect. Thank you, Abhi. Students, here our first term is 1. So power of first term is increase or decrease. It will get the same answer, and the power of b is increasing. So from the first here 1, then b plus b square, b cube, b raised to 4 and b raised to 5. But what about the coefficient? The coefficient we get from the Pascal triangle, but it is easy because your power is 5, and you also get the coefficient with the help of this NCK. It means your first term is NC0. NC0. NC0 is what, dear students?
1.
1.
1, ma'am.
1. So 1 into 1. So our final answer is 1. For the next, here the coefficient is NC1. Our N is 5. So
Yeah,
5.
5. Okay. Now next 5C1.
10 b square.
Just a minute. 5C1, 5C2, 5C3, 5C4 and 5C5. So we get this answer. So 5C0 is 1 for the coefficient of the first term. 5C1 is the coefficient of the second term. 5C2 is, what is 5C2?
10.
10.
10.
Third term, मतलब 10.
And 5C3, it is again
10.
20.
10.
10. 5C4,
5.
5.
5.
5. Okay. So 5 b raised to 4 and the last 5c5 is
1.
1.
1.
So b raised to
1.
5. Okay. So without using Pascal triangle, you can directly simplify any higher power term, or we can say any higher power binomial, right? Any higher power binomial with the help of the binomial theorem. So let me the answer of y plus 5, y plus 5 whole raised to 4, y plus 5 whole raised to 4. Give me the final answer. Okay, we'll show you the answer.
Hello. It's gonna be virus.
To 4, 20y cube.
y4 plus 20y cube
20.
plus
500y
150y
plus
square
60y.
is
Okay,
25.
okay, so it is a big value, but it's quite easy with the help of the binomial theorem, right?
Theorem.
Okay.
Yeah.
Now, I will ask you some more questions.
Ma'am, how many chapters are in our syllabus?
In which these basic maths?
Yes,
Yeah,
ma'am. For
yeah,
N1, how many chapters we have to prepare,
In
ma'am?
this basic maths, see, first we learn indices, surds and logarithm, today binomial theorem, factorization,
yeah.
trigonometry, differentiation and integration. Okay, these topics we discussed before starting the engineering mathematics. So, students, give me the answer of this first, this one, question number 9. Last question. Second last question. What is the coefficient of x in the expansion of 3x plus 1 upon y whole cube? I just want the coefficient of x. Okay. I don't want the whole answer. I just want the answer of coefficient of x.
Nine.
Coefficient of x is 9.
9.
Okay. Anyone?
3. Ma'am, 9
9
by
upon
2 is coming. Ma'am, 9 by 2 is coming.
By 2? By 2 how? I just want.
9.
See, our first term is
9.
3x, so 3x
27.
cube, 1 upon y, whole raised to 6, right? 3 into 3x square, 1 upon y, plus 3 into 3x, 1 upon y is to 2.
9.
Just a minute. And the last one is 3x raised to 0, 1 upon y whole cube. We want to find the coefficient of x, and the coefficient of x is 9 upon
Ma'am,
y.
coefficient of x is 9 by y square.
Yes, coefficient of x is 9 by y square, right? This 9 x 1 upon y square. So the coefficient of x is 9 by y square, right? Now give me the answer of question number 5. That is, using the binomial theorem, expand x minus 4 raised to 6 and find the coefficient of x raised to 4.
Ma'am,
Yes,
ma'am, one doubt was there in
Yes.
previous question number 9.
yes.
We were having one formula, ma'am. I don't remember exactly the formula for finding just a coefficient. It was something TR plus 1 equal to NCR A raised to
Just wait.
N minus
And
M B raised
see summation k 0 to n and ck a raised to n minus k b raised to k.
T. So we can use this formula directly in the examination or some
Yes, of course.
rather showing all this method. It will take some
Friends,
time.
our lecture will be over very shortly. I will share you the PDF after completing the whole all topic. Okay. If you get any query, then please contact me
Ma'am,
personally through WhatsApp. Yes.
so are we having this much only in binomial theorem, or the middle term and all will be teach in the next lecture?
No, this topic is completed today. In the
Okay.
binomial theorem, it's completed today. From tomorrow,
40.
we get the new topic. Okay.
And
Okay.
Question
coefficient of
number
x
5
raised to 4
answer
is
is 240.